Welcome, welcome. Today we're going to talk about integer exponents. We're going to use our math superpowers, and when we're talking about power, we're really talking about exponents. Just go ahead and pause the video, figure out what page number this is, and add it to your table of contents. Go to a fresh page and put this entry in. So just like multiplication represents repeated addition, exponents represent repeated multiplication. And they come in handy for science problems and other problems. So for example, the cells of an organism divide once every hour. Starts as one cell, but after an hour it's 2 cells. After 2 hours it's 4 cells. How many cells will it have after 6 hours? So another way we can represent that is it's timesing by 2, and it's happening 6 times. So an exponent, again, can represent the situation, help us solve the problem. All right, we're going to start with a little review song.
A base exponent. A power's what you get when you multiply a number by itself one or more times. To give you one example, let's look at powers of the number 5. 5 times 5 is 25. 5 times 5 times 5 is 125. 5 times 5 times 5 times 5 is 625. There's 2 parts of a power, a base and an exponent. The base is on the bottom, it's the number being multiplied. The exponent's on the top, it tells you how many times the base is multiplied by. Where's the base? The base is on the bottom. Where's the exponent? The exponent's on the top. 5 times 5 is 25. 5 times 5 times 5 is 125. 5 times 5 times 5 times 5 is 625. Now let's look at the 3 different forms of exponents. You might find that you already know them. 2 to the 3 is known as the exponent form. It's because there's an exponent in there. 2 times 2 times 2 is the expanded form. It's because you've expanded the exponent form. And the result of 8 is the standard form. A plain number is the standard.
I hope you enjoyed that little song, but what the heck did it teach us? It was just a review that a power is repeated multiplication. The bottom number is the base. The top number, the exponent, tells us how many times that the base was multiplied or used as a factor. So for example, if we have half times a half times a half, that part here can be represented as 1/2 to the 3rd power. 3 times 3 times 3 is 3 to the 4th, and there we go. We can also have fun with letters. So we have this business here. We can count, hey, we have 2 A's, put them together. We have 3 B's, put those together and group them up. A squared times B squared. Sorry, A squared times B to the 3rd is what that can be represented as. So grab your scratch paper, press pause, try these 2, and we'll go over the answer tomorrow. We should know how to go the other way too. So we should, bring it to the junior high level and figure out what all this business means. So 3 squared really means 3 times 3, which is 9. 5 to the 4th means 5 times 5 times 5 times 5. Whew. All right, everyone. And let's sing it. 625. Haha. All right, and a basic calculator is totally allowed on these types of problems. So 1/3 to the 4th power would be a third. Ooh, goodness, times a third. Hard to write on this little device of mine. Times a third. So we multiply all the top numbers together and we get 1. And then we have 3 times 3 times 3 times 3, which is 81. So that comes out to be 1/81. And we can have more complicated things like this, but we just basically evaluate each part and then put it together. So 3 squared would be 9. 4 to the 4th power would be 4 times 4, which would be 256. And then we can use our handy dandy calculator to multiply all that business together, and you get 2,304. Fun times. Okay. All right, press pause, grab your scratch paper, give this a try. We'll talk about it tomorrow. All right, well, what about some strange things? We can use patterns to figure out what we don't know. So let's look at our powers of 5 here. So we're going to go backwards. So 5 to the 4th is 625, 5 to the 3rd, 125, 5 squared is 25, 5 to the 1st is 5, and so on. So we can look here and see what's going on with the 4s. Boom, and we can look at the 3s. Okay, everything looking good there. So how do we get from here to here? What's happening? Okay, maybe that might be a little bit hard to see. So let's look here. How do we get from that 25 to that 5? What are we doing? How do we get from the 16 to the 4? How do we get from the 9 to the 3? Hopefully you can see that up here we're dividing by 5. 25 divided by 5 is 5. Here we're dividing by 4. Here we're dividing by 3. Let's see if that pattern rules for the whole thing. This divided by 5 is actually that, and dividing by 5 is that, dividing by 5. Here we are, we're dividing by 4, dividing by 4, dividing by 4, dividing by 3, dividing by 3, dividing by 3. So let's keep it rolling. What is 5 divided by 5? It is 1. What is 4 divided by 4? 1. What is 3 divided by 3? 1. So what can we conclude? Any number to a 0 power is 1. So 3 to the 0 power is 1. And 12 to the 0 power is 1. Weird, huh? Press pause, add that to your notes. Okay, how low can we go? Can we have negative exponents? You can pause if you need some time to figure out that joke. So let's continue the pattern here. So we know that is 1. So what is 1 divided by 5? Well, that would be 1/5. What's that divided by 5? That would be 1/25. Same with 4. What is 1 divided by 4? Well, that's 1/4. And what would happen if we divided that by 4 as well? We would get 1/16. With the 3's, we would get 1 divided by 3 is 1/3. And then we take the third and we divide it by 3 and we get 1/9. Another way we can write these is as 1/5 to the 1st power and 1/5 to the 2nd power, 1/4 to the 1st power, 1/4 to the 2nd power, 1/3 to the 1st power, 1/3 to the 2nd power. So when we have negative exponents, it doesn't mean we have a negative answer or a negative number. It just means that we're going low. We're going underneath the fraction bar right there. And our exponent is going to turn itself positive and end up down there. So a general rule for a to the 0 power when a is not 0, well, anything to the 0 power is 1. And a general rule for a to the negative n power a to the negative n is really the same as 1 over a to the n, meaning 1 over whatever the heck it was, but not negative anymore. All right, so a couple more examples. 4 to the negative third is really the same as 1 over 4 to the third, and we can just leave it like that. 2 to the negative 2 is really the same as 1 over 2 squared. We could go farther if we wanted to and write it as 1 to the fourth, but really this right here, this is fine. Just understand that it's the same. And 5 to the negative fourth is the same as 1 over 5 to the fourth power. All right, let's do a couple more examples and then you can pause and write it in. So 7 to the negative second power, hopefully you're like figuring this business out by now, is going to be 1 over 7 squared. 4 to the negative third is just 1 over 4 to the third. And last but not least, 5 to the negative fourth is really 1 over 5 to the fourth power. Hit pause, copy down this rule up here as well as the examples, and I will see you in class tomorrow. Have your notes completed and ready to go.